Welcome to Important Updates, your trusted source for breaking headlines, global insights, and sharp analysis from around the world. If you are new here, do not forget to hit that subscribe button so that you never miss an update. I bet you didn't know Huawei was about to change the game in chip technology. January 19, 2026 began like any other at TSMC's headquarters in Hsinchu, Taiwan. The sun rose over the city, casting a golden glow on the glass and steel of the world's most advanced chipmaker. Inside, the hum of innovation was as steady as ever. Engineers, in pristine, clean room suits, moved with practiced precision, inspecting wafers and reviewing the latest yield reports. Their confidence was palpable. TSMC had long been the undisputed leader in the chip-making world, setting the pace for the entire industry. Their roadmap was clear: smaller, faster, better. Every milestone was meticulously planned, every challenge anticipated. For TSMC, it was business as usual, another day pushing the boundaries of Moore's Law. But then, in a quiet corner office, a senior executive's routine was shattered. He spotted a new patent filing: quad-gate nanosheet transistor architecture. The applicant, Huawei. The name alone sent a ripple of surprise through his mind. He read the abstract, then read it again, hardly believing what he saw. This wasn't just another incremental improvement, it was a leap, a bold claim that threatened to upend everything TSMC thought it knew about the competition. The blueprint described a 2nm chip, but with a radical new approach. The technical details hinted at a breakthrough that could redefine performance and efficiency, something no one at TSMC had anticipated. Within minutes, TSMC's digital corridors buzzed with disbelief. Emails flew, chat windows popped, and urgent calls echoed through the halls. The news spread like wildfire, igniting a sense of urgency and unease. Emergency meetings were called. Whiteboards filled with frantic sketches and hastily drawn diagrams as engineers and executives tried to make sense of what they were seeing. The atmosphere was electric, charged with both fear and fascination. The design was elegant, audacious, and, most alarmingly, it looked viable. It wasn't just theoretical, it could actually work, and work spectacularly well. No one expected this from Huawei, a company supposedly years behind in advanced chip technology. The shock was total. How had they closed the gap so quickly, and in such a dramatic fashion? In the main conference room, TSMC's top minds stared at the projection, realizing they'd been so focused on perfecting GAFET, they never imagined someone would invent a new path. The realization was sobering. Their greatest rival had just rewritten the rules. It was like perfecting the horse-drawn carriage while someone else patented the engine. The analogy stung, but it captured the moment perfectly. A sudden, seismic shift in the landscape of innovation. Huawei hadn't just changed the game, they'd flipped the board, scattering the pieces, and forcing everyone to rethink their next move. The sense of competition was now sharper than ever. The race for the future of silicon had just exploded wide open. What had started as an ordinary day at TSMC had become the dawn of a new era, one where nothing could be taken for granted, and every player would have to fight harder than ever to stay ahead. Let's break it down. When you hear 2nm chip, it sounds almost impossibly tiny, right? But what does that actually mean? And why is everyone in tech so excited about it? A 2nm chip isn't literally 2 nanometers wide. It's more like a new generation, similar to how car companies release new models every year. The 2nm label refers to the manufacturing process, not the chip's actual size. Each new node means engineers can squeeze even more transistors into the same tiny space, which boosts both computing power and energy efficiency. It's like fitting more brains into the same head. Transistors are microscopic switches, billions, sometimes trillions of them, flicking on and off at lightning speed to run your apps, process your photos, and stream your videos. They're the real workhorses inside every device. Shrinking these switches is the secret sauce behind why your phone, laptop, and even your smartwatch get faster, smarter, and more efficient every year. Smaller transistors mean less power wasted and more features packed in. The leap from 5 to 3 nanometers was already a massive engineering feat. Now 2 nanometers takes us into uncharted territory, pushing the limits of what's physically possible. At this scale, transistors are just a few atoms across. We're talking about structures so small that the rules of classical physics start to break down, and quantum effects begin to wreak havoc. Electrons can actually tunnel through barriers that should block them, causing errors, data loss, and wasted energy. It's like trying to build a dam out of sand grains. Water just seeps through. This is the wall every chipmaker is desperately trying to climb. It's a race against the laws of physics, demanding new materials, new designs, and new ways of thinking. A true 2nm chip isn't just about making things smaller. It's about solving the mysteries of the atomic world and rewriting the rules of technology at the smallest scale. Whoever cracks this code first will define the next decade of tech, setting the pace for the entire industry and shaping the devices we all use. These chips will power the next wave of artificial intelligence, supercomputers, and smart devices. The prize: industry dominance, and the chance to lead the world into a new era of innovation. The stakes? Nothing less than the future of technology itself. The race for 2nm is on and the world is watching. So, what did Huawei actually patent? Not just a smaller transistor, but a new kind. Today's cutting edge is GAAFET, where the gate wraps around the channel on all sides, like your hand gripping a hose. Huawei's quad gate design uses 4 independent gates, each controlling the flow of electrons separately. Imagine 4 fingers, each able to press the hose differently, unprecedented control at the atomic scale. These gates can be tuned individually, 2 for speed, 4 for efficiency, adapting on the fly. It's like a sports car morphing into an economy sedan when needed. This tackles the biggest 2nm problems: electron leakage and heat. More precise control means less wasted power and heat. Instead of thicker walls, it's smarter, adaptable force fields for electrons. To grasp Huawei's leap, you need to see TSMC's current playbook. TSMC dominated with FinFET, transistors shaped like fins with gates on 3 sides. This design powered the industry from 22 to 5 nanometers, but as they shrank further, FinFET hit its limits. Too much electron leakage. Enter GAAFET. The channel becomes a nanosheet, and the gate wraps all around. This gave TSMC better control, but manufacturing billions of these at atomic precision is mind-boggling. Their roadmap was simple, perfect JAAFE at 3 nanometers, then pushed to 2, then 1.4. The whole industry followed. Samsung, Intel, everyone. JAEE was the future, the only path to sub-3 nanometer chips, or so everyone thought. Now, Huawei's patent throws that certainty into chaos. Let's dive into the battle of old versus new. On one side, we have TSMC's GAAFET technology, which stands as the current champion in the semiconductor world. GAAFET offers exceptional control over current flow, packs transistors densely, and has already proven itself in real-world products. It's the result of years, decades really, of relentless innovation, trial and error, and engineering breakthroughs. This technology didn't appear overnight. It's the product of a long, fascinating evolution, stretching from the earliest, clunky computer chips to today's ultra-sophisticated designs. Now, enter Huawei's quad gate. Its main advantage? Dynamic, fine-grained control. Instead of just one gate, each transistor has 4 independent gates, allowing for a level of flexibility that's never been seen before. Think of it like the difference between flipping a basic light switch and using a sophisticated dimmer with multiple sliders. With quad gate, you can adjust each gate independently, tailoring performance in real time. This means every single transistor can be reconfigured on the fly, optimized for raw speed when you need power, or dialed back for maximum efficiency when you want to save energy. It's a level of adaptability that could transform how chips work. Imagine your phone's chip instantly shifting gears, blazing fast for AI tasks, then ultra-efficient for standby mode, all without missing a beat. This could make devices smarter, faster, and more energy efficient than ever before. GAAFET, as advanced as it is, simply can't offer this kind of per-transistor reconfigurability. Its architecture is powerful, but not as flexible at the atomic level. But here's the catch: manufacturing. GAAFET is already pushing the limits of what's possible in chip fabrication, requiring extreme precision and massive investment. Quad gate's complexity takes things even further. Building and wiring 4 independent gates at the atomic scale is a monumental challenge, one that's never been solved before. TSMC spent billions to master GAAFET. For Huawei, cracking quad gate means facing an even tougher, more expensive puzzle, with no guarantee of success. But if they succeed, the payoff could be enormous. Huawei could leapfrog the entire industry, setting a new standard for chip performance and efficiency. The risks are huge: billions of dollars, years of research, and the possibility of failure. But the potential rewards are just as massive, with the power to reshape the global tech landscape. In the end, the future of chips, and maybe the future of technology itself, may hinge on who solves this puzzle first. The shock wasn't just the tech, it was that it came from Huawei. Sanctions had cut Huawei off from advanced manufacturing, so the world assumed they were stuck optimizing old tech. Everyone thought they were years behind, not secretly inventing the next leap. The industry's built on incremental steps, not wild leaps. TSMC and others focused on perfecting GAFET, never imagining someone would sidestep the race entirely. But Huawei, locked out of the game, poured resources into fundamental R&D. The sanctions meant they had nothing to lose and everything to gain by reinventing the rules. TSMC's blind spot was thinking the race was only on their track. This patent's impact goes far beyond Huawei and TSMC. For years, US control over chip tech has been a geopolitical lever. If Huawei can manufacture this, China could leapfrog the West in foundational tech. A domestically designed, produced 2nm chip would power China's AI, military, and telecom, independent of foreign supply chains. For the industry, it's a wake-up call. Do you stick with GAFET or chase Quadgate? This could spark a new chip space race, with billions poured into R&D. We might see two parallel tech ecosystems, GAFET versus Quadgate, splitting standards and supply chains. The global tech landscape just got a lot more unpredictable. So, what does this mean for your phone or laptop? In the short term, not much. This is just a patent, not a product. It'll take years and billions to turn this into reality. Your next phone will still run on GAFET chips, but 5 to 7 years from now, if Huawei succeeds, your devices could see a massive leap. Imagine a phone lasting days on a charge, or a laptop editing 8K video without breaking a sweat. Real-time translation, AR glasses, and more, all possible with this kind of power. Disruptive tech means faster innovation and lower prices for consumers. The race is on, and that's good news for everyone who loves gadgets. The next decade could be the most exciting yet. To sum up, Huawei's Quadgate patent is more than a technical document, it's a shot across the bow. It's proof that constraints can drive radical innovation. Now TSMC, Samsung, and Intel must decide, stick with GAFET or hedge their bets. The journey from patent to product is long and treacherous. Huawei's just cleared the first hurdle. The next steps, manufacturing, yields, building an ecosystem, are even harder. But this marks a turning point, the end of a unipolar chip era, and the start of a new, multipolar race. Geopolitics will fuel innovation, pushing the brightest minds to new heights. For tech lovers, the future just got a lot more exciting and unpredictable. The race to 2 nanometers is on, and the track has changed forever.